Hello differential equation students, and welcome back. Again, this is unit number 5. This will be video number 2 for our example number 1. Okay, and what we want to do is we wanted to do a power series solution to a differential equation with a singular solution, right? Or about a singular point, sorry. So what we usually do is we take this thing and we would take 2x and we set it equal to 0. And we see that x equals 0, okay? And that means that because x equals 0, right, this is the root of this polynomial out here, that x equals 0 is a singular point. And then all other points that we were to go about would be ordinary. Well, I do want to do an example with a singular point. So I want to solve this differential equation about x equals 0, which of course then instantly makes this a singular one, right? It does make this a singular one. Now I should go through and I should check it to make sure that this thing is not the same root as my other ones, right? Oh, right here, there is no x, right? There's no x here, so we don't even have to really worry about this one. Checking that one. Now, this one here does have an x. If I were to plug in 0 there, it does not make this whole polynomial 0, so I'm good. It's not a root to that, so x equals 0 I should be good to go with, okay? So now what we're thinking about is we want to do the same type of things that we've done before. And the way we have to think about that was, well, in the last video, I said what y double prime was, which is the summation as n equals 0 to infinity of c sub n plus r, n plus r minus 1, and x to the n plus r minus 2. Okay, now this whole thing, right, had a 2x sitting out here, right? And then the next part, I would have a plus 1 plus x, and then that's y prime. Well, y prime, again, from last video, n to infinity, or 0, n equals 0 to infinity of c sub n, then that's n plus r, x to the n plus r minus 1, right? And then hopefully this is all coming together well for you. And then I have plus, and it's just a y here, so I just do my original, right, which was n equals 0 to infinity c sub n x to the n plus r, okay? And of course, this whole thing equals 0, right? So you can see the black part I kind of tried to keep straight so you can understand where I'm getting this equation and where it falls into play. And from here, what I need to do is I'm going to need to simplify this a little bit. And, you know, this hopefully won't be too bad after we've done the last videos. Like, I want to push this 2x inside here. Well, when I push this x to the first power in, it should take one of these minus 2's out, right? It should take this thing down to just a minus 1, which would then leave my 2 inside. Let's space this out a little more. So I have the summation n equals 0 to infinity of 2 c sub n plus r, n plus r minus 1, x to the n plus r minus 1. Okay, and then I have, well, here when I distribute this, really it creates 2 summations. This would be n equals 0 to infinity of the c sub n plus r, x to the n plus r minus 1, right? That's this coming in here. Now I'll do the next one. Well, same type of things happening. This x is to the first power. When I bring it in, it'll cancel out with this negative 1. Which leaves me with c sub n plus r, x to the n plus r. And then finally here at the end, I haven't done really anything. I can't really do anything crazy to this one. So I have c sub n x to the n plus r, and that equals 0. Okay, so hopefully that part right there is not too terrible. All right. Now normally what we would do is we would be thinking about how to make these powers up here, right? How to make these powers up here match. Now clearly you can see it's n plus r here, and normally it's x to the n. This r is going to give us a little bit of trouble, but what if we thought like just the goal in general was to sub out the n for the k and have it look like this, right? In this case, you'd want the k then to equal this n minus 1. But what happens is then you end up getting k plus 1 equals n. And if you were to plug an n down here, you'd have a negative index, which we can't have this negative index. We can't have this negative index down here on a summation. So that gives me a big problem. Like, if you're not understanding what I'm saying, if I plugged a k plus 1 and write that n right here, in here, and then I solve it, that's a negative 1. That's an issue. Okay, we can't be having that in the summation. So how we get around that is we need to bump it up, right? Because if this were like if you mentally pictured if this was a 1 here, then when I plug that in, I would subtract over and it would just be a k equals 0, and then we'd feel good with it. So that's going to be the goal, right? To get this to be k equals 0, well, that means I needed this to be a 1. How do I get this part right here? And the only one that I really struggle with, right, are these two, because they have this minus 1 here. So I'm going to need this n equals 1 in the index. Well, I get that by giving n equals 0. I just get those terms. So if I do that, right, if I do that here, I plug in 0, that's 2c sub 0. That's a terrible 0. Let's try that again. 2c sub 0. And then that's a 0 there, so that's an r. And then I have a 0 there, so it's times r minus 1. And then it's x to the r minus 1, right? Over here, I would have, well, let's write the rest of this out here. Then it's plus the summation. Well, I just used the 0, so now it's just a 1 to infinity 2 sub n plus r times n plus r minus 1 x to the n plus r minus 1. Now this one over here, I would have a c sub 0 then that's what, an r, and that would be r minus 1. And then after that, I have plus the summation of n equals 1 to infinity of my c sub n plus r, x to the n plus r minus 1. Now if we just keep with, remember I've only dealing with these two here in purple, and if we just keep trying to go and we try to simplify this down a little bit more, right? When I combine these, right, these coefficients out here, I see this is x to the r minus 1 here and here. So I would have 2c naught r plus c naught r. Now those both had my, oh, and I've already forgotten, that would be, mess me up. I also forgot this r minus 1, and then it would be plus c naught r, right? And those both have x to the r minus 1. All I've dealt with so far is this term and this term. Now these two, it looks like I'm basically ready to just like combine these, right? I should be able to just kind of smash these in together. This doesn't look too terrible to do. Let's double check. This is x to the n plus r minus 1. Yep, those look like the exact same. Of course, what we could do is, because we want this to end up being this part up here, I just want this to end up being in x to the k plus r. I can just go through and I can just say, okay, well, I want it to be k plus r, which means I'm going to need k to equal n minus 1, which then in turn means that k plus 1 equals n. When I plug that in over here, I'm going to have to subtract 1 over and I'll get the k equals 0 to infinity of, well, now I have to go through and I just have to plug in this this n equals k plus 1. So here I'd have 2 c sub k plus 1, then that's k plus 1 plus r, k plus 1 plus r minus 1, x to the k plus r. Okay, and then I have my plus. Remember, I've already taken this term out over here, so if I sum, this is another. Okay, well, what I need? Well, it would be the actual same thing, so this is k equals 0 to infinity. This is c sub k plus 1, and this is k plus 1 plus r, x to the k plus r. Okay. Now, I am continuing to mess with this purple stuff, but what you can see is now all of a sudden, right, now all of a sudden I have this goal of getting k plus r, and I made it there. The question is, I can get this to stay here, can I get these up here to be that as well? And the answer to that is, yeah, I think that's rather easy. If I just let n equal k for both of them, I should get that, right? I should have that pretty quickly. So I have plus, and I'll try to leave it so I can see here. This would be a k equals 0 to infinity of c sub k, k plus r out here up front, and then that's x to the k plus r up top. That's this first one. I can't really see the second one here, but I'm pretty sure that it starts with the summation sign. It'll be k equals 0 to infinity of, well, that's c sub k, and then that's x to the k plus r. And then technically remember that all of this thing here equals 0. Okay. Obviously, as we're going through the problem, it's very wise to pause the video and make sure that you're understanding where I'm getting these things and how they're kind of working together here. Okay, so we're moving right along, right? We have this coefficient sitting out here with this x to the r plus minus 1. That's fine and dandy. The big thing now is to try to make this into one giant summation, which I think I'll be able to do. I already have k equals 0 on all of them, and I already have x to the k plus r for all of them, right, which is going to be extremely helpful here. So when I go to put these together now, I would do plus summation k equals 0 to infinity. And now this is where everybody kind of likes to do everything a little bit differently. I see that these have this k plus 1, these two do. So what I want to do is I'm going to do c k plus 1 times now. And what would this have? This would have this 2 times k plus r plus 1. Just kind of makes more sense to write this part like this. And then times, well, these 1's cancel out, right? So then it's just k plus r here. Now it's plus, it'd be a k plus r plus 1, right? Now this is where some people would also factor this portion out, okay? But it's up to you. And then we have, those all have the c sub k plus 1. Well, the next part would have c sub k's, and what is in there would be my k plus r, right, this part here, Oh, and then because I technically I'm taking it out, so that would be a 1 here. Now, I hate these giant brackets, but I'm going to do it anyway. This whole thing has x to the k plus r. And then I didn't touch this at all. Oh, so close to being perfect. I think you get my point though. Okay, those would be sitting right in here, right? That's plus that equals 0. Okay. Now, I think this is a great spot to stop this specific video. Yes, the problem is not complete, but this video, it's a great time to stop it. That way, it'll give you a chance to, 1, try to finish solving it if you would like, or 2, make sure that you're solid to this point here, okay? Let's come back to 6.3, video 2B for the final solution.